Python has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type, complex. Hey everyone, welcome back. Today we're diving into one of Python's lesser used but very powerful numeric data types, the complex type. If you're dealing with mathematics, engineering, or scientific computing, this is a tool you'll definitely want to understand. Let's get into it. In Python, complex is a built-in data type that represents complex numbers, numbers with both a real part and an imaginary part. Python uses j to represent the imaginary unit. So 4j means 4 times the square root of -1. Complex numbers are widely used in fields like electrical engineering, quantum mechanics, signal processing, control systems, and even 3D graphics and simulations. They give us a way to represent values that have both a magnitude and a direction, beyond the real number line. You'll use complex numbers in Python when you're performing calculations with imaginary components. You need to model waves, oscillations, or rotation. You're building scientific or mathematical applications. You're using libraries like NumPy or SciPy that support complex arrays and operations. Python makes it easy to work with complex numbers, just like any other numeric type. Here's what you should know. A complex number has two parts, real and imag. You can create them with a literal like 3 plus 4j, or with the complex constructor. Python supports arithmetic with complex numbers, plus, minus, times, division, and exponentiation. You can access the real and imaginary parts using .real and .imag. And you can use the abs function to get the magnitude, or the modulus, of the complex number. Let's look at some code examples. In our first one, we'll just create a couple of complex numbers. No, we can do that literally, as we do here for the complex number a, or you can use the complex function, b. If you use the complex function, first provide the real part, and then the imaginary coefficient. We can also do arithmetic on our complex numbers. Note here how we show this using addition and then multiplication. You can access directly the real and the imaginary parts. Use .real to get at the real portion of the imaginary number, and use .imag to get to the coefficient of the imaginary component. Imaginary numbers come with a full complement of methods that you can use to work with the numbers. Here we illustrate the conjugate method and its result. If you want to get the magnitude of an imaginary number, simply use the abs function. Here we see the result is 3.6 plus a few other decimal values, which is basically calculated by summing the squares of the real and imaginary coefficient and then taking the sum square root. So complex numbers in Python behave just like you'd expect from your math or your engineering classes, but with the power of code. So that's a quick introduction to Python's complex type. Whether you're building simulations, processing signals, or just learning more about math in Python, complex numbers are easy to use and fully integrated with Python's number system. If you found this video helpful, give it a like, subscribe for more coding tutorials, and drop a comment if you've used complex numbers in a real project, or you want to. Thanks for watching, and as always, happy coding.